Hello everyone. This video is regarding module 5, the first part, ferrous alloys. As the name itself suggests, ferrous alloys means the alloy is having iron as the main constituent, and the other elements can be phosphorus, sulfur, manganese, and others. Okay. In our discussion, mainly we have like in generally whenever we have to bifurcate metals, it's usually like ferrous and non-ferrous metals or alloys to be precise. In our discussion in this module 5, we have mainly ferrous metals, steel, and cast iron. We are not discussing regarding non-ferrous alloys, so we shall be discussing on steel and cast iron. Okay, and just for the information, non-ferrous alloys, there are, like, as you know, aluminium, copper, manganese, nickel, all these things. Okay, so be it whatever, ferrous or non-ferrous, both the types, they have their own characteristics, merits, demerits, and everything. Okay, like if it's a material, it will have its own plus points, the pros and the cons, and definitely the applications also, and the not much of use also. Okay, anyway, so our discussion is on ferrous, especially on steel. Okay, now steel is like a product which is used very much in the applications, not just for the industrial but also for the domestic purpose. Okay, it's a typical engineering material which has a lot of modern engineering practice. Okay, and uh, there are certain characteristics on the steel for which we have to concentrate also. It is pretty strong and very much machinable. Now that's very important because you can use it for whatever shapes that you desire for. And its important properties, it is ductile. That is very, very important. Good conductor of electric current, and it has this shining sort of an excellent surface finish. So this makes steel to be used for majority of the applications. Okay, so moving on, you have the type of carbon steels. Okay, usually when I say carbon steels, it refers to plain carbon steels. That means to say, steel, as usual, I mean, as you know, that it is a combination of iron and carbon. And steel which has only carbon up to 2%, only it will be called steel. Beyond that, it will be called cast iron. So when I say plain carbon steel, I mean to say it has iron, obviously, in the maximum content, with carbon percentage within 2%. Okay, now considering the amount of carbon being present in the plain carbon steel, there are four types: low carbon steel, medium carbon, high carbon, and ultra high carbon. Low carbon means within 0.25, 0.03 to 0.25%. Medium is between 0.25 to 0.59% carbon. High carbon is up to 1%, and ultra high is up to 2%, and not beyond that, obviously, because beyond that it would be cast iron. Okay, now what are the properties and applications of each type of the carbon steel? That is given in detail, and that's pretty easier for you to just read and understand. Nothing too much explain, it's just very theoretical. So I thought it's not required so much that I have to discuss on that, like explain it so much in detail. It's self-explanatory, so don't worry, all the required materials are there in your slides. Please go through that. Okay, the next thing that you have is, under steel, you have steel designation. Now how it is designated? So the Society of Automotive Engineers, SAE, they have established the standards to specific analysis of the steels. Okay, basically it has 4-digit number, SAE 1040, like the example SA 1040 means the first digit will indicate the carbon steel. And again the number will vary. Okay, now when I say SAE 1040 is a carbon steel with 0.4% carbon content. For plain carbon steel, first two digits are 1 and 0. Alloy steels, they are designated by other two initial two-digit combinations. I think I'm confusing you. Okay, see, what I mean to say here is, now when I say SAE 1040, SAE 2515, SAE 5120, the first digit 1, 2, 5, this is all specific for certain metals. Now 1 is for carbon steel, 2 is for nickel steel, and 5 is for chromium steel. What I mean to say is, when I say carbon steel, that means it has carbon. Nickel steel means along with carbon it has nickel, iron and carbon. Chromium means along with iron and carbon it has chromium. So that number given refers to, this first digit refers to what is that additional alloy that's been added on. Okay, now the second digit will indicate that there is no modification in the alloy. Now in this case 1040, there is no modification, okay, because it's a plain carbon steel. Suppose there are numbers like 5, 1 elsewhere. That means the alloying element is 5% nickel. As I told you, carbon steel means it will have just iron and carbon, nothing else. That is why it is 0. Now you have here nickel. That means how much of nickel? 5%. You have chromium. How much of chromium? 1%. Got it? So how much of that extra alloying is added, element is added, that is what the second digit shows. Now the last two digits shows the percentage of carbon. Now in this case there is 0.4%, not 40%, 0.4%. Okay, obviously it can't be 40%, so it's 0.4% carbon. In this case 0.15% carbon. In this case 0.20% carbon. Okay, hope I made you clear with this steel designation. Okay, if you have doubt, please get back and try to understand that in this video. Okay, next, moving on, you have cast iron. As I told you, steel and cast iron, it's like the difference is mainly with the percentages of carbon. So the iron content having majorly iron but having content of carbon with more than 2%, it becomes cast iron. Okay, and only carbon is the main alloying element in it. Alright, so in that cast iron you have majorly 4 types: grey cast iron, white cast iron, malleable cast iron, and spheroidal graphite iron. If you remember grey cast iron, white cast iron, this was discussed previously in the initial, I mean not initial exactly, but yeah, sort of in the initial of the 4th module. Okay, that is heat treatment, when I was discussing on annealing. Okay, just remember, get back to that annealing video, you will get it, like when I was discussing on full annealing process, that grey cast iron, white cast iron. Okay, so yeah, anyway, grey cast iron, it is like in which most or all of the carbon is not combined in the form of graphite flakes. That is, its name is grey cast iron because mainly it has cementite and pearlite in it. Right, less percentages of pearlite and more percentages of cementite will be there, and cementite has this gray kind of flakes. Okay, sort of like graphite flakes are there. So that gives it the color of grey. If you have referred to solidification of cast iron, in detail the formation of grey cast iron is discussed. So please go through that. Okay. Again, white cast iron, it is combination of pearlite and alpha ferrite, where you have the major appearance of pearlite in it. Okay, so that is the reason it's quite it's called white cast iron, because it has major of pearlite with very shiny experience, very shiny appearance. Pearlite means, yeah, it is white and it shines like a pearl. That's why the name pearlite. So because of that pearlite, the name comes as white cast iron. Even this is also discussed in solidification of steel. Please go through that. Okay. Next is malleable cast iron. Now here, most or all of the carbon is not combined in the form of irregular round particles called the temper carbon. Now this is what is obtained by heat treatment of white cast iron. So it's just the continuation. If you know the formation of white cast iron, further when you heat treat that white cast iron, you will be getting the malleable cast iron. Okay. Next is spheroidal graphite or nodular iron or ductile iron, a special alloy addition where carbon is not at all combined in the form of compact spheroids. That is, you have this carbon being in the form of like a spheroidal shape. Okay, now this is about the spheroidal graphite iron. It's okay if you've not understood what I mean to say here. The in detail explanation of each and everything, and needless to say, the composition, properties, application, microstructure of each and every forms of cast iron is in the textbook. Please follow them. Okay, you have to be particular with all these things, and again, it's just self-explanatory. I need not have to explain the same thing. It'll be just like I'm reading it out. Okay, so it's that self-explanatory. I think it should be easier for you to understand. And you have the graphical the pictorial representation. This is not required so much, but main thing is you need to know the composition, properties, application, and microstructure. All the four for the types of cast iron and for the type of steels. Okay, carbon steels. So hope I'm clear with this. This is the first part of the fifth module. Next, I'll be dealing with composites. Okay. Now, another thing is you have glass, ceramics, and clay. Okay. So that is again the usual thing. You don't have the manufacturement, the like how the glass is manufactured, the composition and everything. You just have the basic introduction of glass, ceramics, and clay. So I will be sharing the notes on that too, the content of it, which is just a theoretical and self-explanatory part. So I won't be explaining that again. I will be presenting that also on the slides. Okay. Again, all the details are also present in the slides. Don't worry. Go through it. You will be able to understand. Okay. But better, I would suggest you please refer the solidification of cast iron and solidification of steels before you come to this topic, so that will be easier for you to understand. Okay, hope I made you clear. Next video I'll meet you with composites. That is the last part of fifth module. Okay, thank you and bye.